So the question we were trying to answer in this experiment was, what are the effects of corrosion on aluminum, copper, iron, and tin?
And what we hypothesized for this experiment was that all of the metals would corrode differently, of course, but we hypothesized that aluminum would corrode the least. But before we go to the results, we first have to do how corrosion works.
So the reason metals corrode is because they are in environments in which they are chemically unstable. Also, metals are the elements that tend to lose electrons in chemical reactions, and non-metals tend to gain electrons. When a metal loses electrons to oxygen, this process is called oxidation. For example, when iron atoms oxidize, they go from neutral iron atoms to positively charged iron ions.
And this diagram basically just explains how oxidation works. This smaller atom right here represents the metal, and this represents oxygen. Oxygen gets reduced because it has electrons added to it, and the metal is oxidized because it gives its electrons to oxygen and it forms an ionic bond.
So the method we used to test our hypothesis was we placed our 4 different types of metal into salt solution for 3 weeks or 21 days. Then we removed them from the salt solution and let it dry. After it dried, since we did this twice to ensure reliability, we took the averages of the post-experiment mass.
Yeah, and our variables for this experiment, the independent variable was the metals that we used because that was what we changed, and the dependent variable was the amount of mass that changed for each metal. And some of our constants were the amount and temperature of water, and the amount of salt, and the size of the metal.
So the results we saw of our experiment was that the aluminum had small brown spots on it and a white opaque crystalline substance near the top, near the etching of the chemical symbol. For copper, it had a blue-green substance on its surface, with the tip being black and the back of the copper was a pinkish red hue, as well as just below the black part. After being exposed to air, the pink-red back became a light mauve-purple color. The iron had a reddish-brown substance at the top, but the lower 4/5 had a lighter orange substance streaked across it. The part that did not touch the water was relatively uncorroded. And finally, the tin had a crystalline substance filmed on it, but it was patchy in places, not quite covering the whole piece of metal. Unlike on the aluminum, this substance was clearer and less opaque.
Yeah, and this graph basically just represents the amount of mass that changed. Iron's mass changed the most, then copper, then aluminum, then tin. And that leads us to our conclusion.
So our hypothesis was partly incorrect because we said that the aluminum would show the effects of oxidation least, but our experiment proved it wrong. The metal that oxidized the least in our experiment was tin. Firstly, all the other metals' mass changed, but tin's mass changed the least by 0.045 grams. However, a part of our hypothesis is also correct because of all of the metals showed oxidation differently, if at all. For example, when iron is oxidized and combined with oxygen, it forms a reddish-brown substance called iron oxide or ferric oxide, more commonly alluded to as rust. The chemical equation for the oxidation of iron was 4Fe plus 3O2 plus 6H2O, which equals 4FeOH3.
Yeah, and what happened to the copper was that it formed patina, or basic copper carbonate, and the chemical equation for the oxidation of copper is 2 copper atoms, and then water, carbon dioxide, oxygen forms Cu3OH3CO3. And yeah.
So why did the salt solution affect the aluminum and tin less drastically? Aluminum does not corrode, but it does, however, oxidize. When exposed to moisture and air, it forms a thin, opaque white film on the surface, which, given enough time, can become diamond hard. This protective coating prevents the metal from corroding. Another effect of oxidation on aluminum are small brown spots. These 2 characteristics are aluminum oxide, and the chemical equation for the oxidation of aluminum is 4Al plus 3O2, which equals 2Al2 and O3.
Yeah, and one of the metals in our experiment did not oxidize at all, and that metal was tin. The crystalline substance that was on it was salt crystals from the salt solution that it was in, and that was because the water in the salt solution evaporated enough to leave that residue. And this experiment matters because oxidation and corrosion have real effects in the world. And some of those are danger to construction workers because of corroded metal and the destruction of historically significant artwork and monuments and artifacts. Yeah.
So when all or a majority of atoms on the same metal surface are oxidized, it causes the entire surface to be damaged. One effect of oxidation is that it can be highly dangerous in that it affects things such as construction and can weaken the infrastructure. This increases the risks of injuries in workers and even death. And if the workers are not properly vaccinated, the oxidized metal can harbor tetanus, which can be lethal.
Yeah, and also about corrosion affecting monuments and historically important artwork. One example of this is the Eiffel Tower, and the Eiffel Tower corrodes. So it has to be repainted every once in a while, and that costs $61 billion to do each time. And it's also a high-risk job because earlier coats of paint contain lead, which can be toxic to humans.
Also, the oxidized metal cannot be recycled because the structure is damaged. So the U.S. corrosion study states that the direct cost of metallic corrosion is $276 billion a year.
Yeah. So these are the reasons that we have to study oxidation, and some solutions that can be applied is to coat oxidation-prone metals with oxidation-resistant metals. And that's why we're studying this subject, because it's important to the world.
Thank you.
Thank you.